G'day chemists. So today we're going to talk about a really big separation technique, one that's really common in the lab and in industry. And it's called distillation. It's one we use for separating out two miscible liquids, so homogeneous mixtures of solvents of liquids dissolved in other liquids, or solutes dissolved in other liquids. By the end of this, we want to understand the technique, but also what's the physical property that they're being separated by. So here we have your vocab. Just write this down, pause the video, write it down, and refer back to it as we're going on through the lesson. So here we have our very basic distillation equipment. It's really interesting, like it doesn't matter which laboratory you go into. If you're doing a small scale distillation, the equipment's kind of the same. And we'll see that we've got several pieces of equipment. We've got a distillation flask down the bottom here. We have a condenser, we've got a sort of a tube, a bend tube just here. We have a thermometer. Now this thermometer is actually blocking off, so no gas can leave here, which forces the gas as it boils up to go down the condenser. The condenser is a piece of equipment. This job is to condense out gases, and we'll go through this a bit more formally in a second. And it turns whichever gas is a gas here back into a liquid, but as liquid runs downhill, it drops into the Erlenmeyer flask or the conical flask here. So let's go through this in a little bit more detail. So distillation separates miscible liquids, so liquids that mix in with each other, or solutes from solution. It does this based on the boiling point. So the component with the lowest boiling point is heat, so they're both heated, and the component with the lowest boiling point leaves that solution as a gas. And we need to make sure we maintain the temperature, which is why the thermometer is there at the lower boiling point. And this way, once we do that, the only one which will leave as a gas is the most volatile of the two components of the solution. Now, again, we need to maintain that temperature. So we get it up there, and then we remove the heat or turn the heat down as it continues to rise, depending on what we need to do. So as the more volatile one, it will vaporize, and it will come up the tube here. It can't go any further there, so it's forced down because the pressure's higher into the condenser. And once it's in the condenser cools it down by the cool water that's running through the outside of the condenser, which turns it from a gas back to a liquid. And once it's a liquid, as we said, it runs downhill it's condensed and moves into the Erlenmeyer flask. Now, that which is collected in the conical flask or the Erlenmeyer flask is called the distillate. So the distillate is what's collected at the end. It's used industrially to separate crude oil, but many other places as well. It's a really, really common technique. Now, the energy it's high energy, but it's also really very low on the limitations. It has a high yield, but it requires a lot of maintenance while it's running. You have to really pay close attention to it. I hope that made a lot of sense. If you've got any questions, put them in the comments below and we'll get back to you as quick as we can. Hit the subscribe button so you can keep up to date with everything we're putting out there. And yeah, thanks for watching. Bye now.